All right, good afternoon, grade sevens. I hope that you guys are all having a productive Wednesday so far and that you're ready for us to get going with um, another lesson today. I believe this is now the 14th lesson of the year. So we've made some really good progress so far, guys. We've covered a lot of important topics and we sort of want to keep up with that momentum. Um, I believe over the last 2 weeks, we have been discussing the world of measurements, guys, and we want to continue on that path, wrapping up that section because while it is important, there's still lots of other work for us to cover. So I don't want us to spend too much time on going over one specific section of work. So 2 weeks ago, we chatted about what measurement, the topic of measurement is really all about, right? We broke down the different kinds of calculations that we need to be comfortable with completing to find perimeter, area, surface area, and even volume of different shapes. So today we want to discuss about these last two types of measurement that we haven't yet been through. Last week, we spent a lot of time going through the area of different shapes, right? You guys are now grade seven, so I'm not too worried about your understanding of perimeter. You guys should have practiced that more than enough by now. But we talked about the area of triangles, parallelograms, and then even compound shapes. And I pointed out to you guys that it's very important when we're trying to calculate um, the area of a compound shape that we take the time to try and split our compound shape into more recognizable regular shapes, because we have the area formulae for shapes like squares, rectangles, triangles, and circles, and we don't just have an area formula for some of the more complicated compound shapes that we run into. Okay, now, today, like I said, we're going to move on to talking about surface area and volume. So I'm going to start by sharing my screen with you guys. You can go ahead and write down today's date, which is the 23rd of April, and then also copy down the heading. We're going to write down one or two notes and then dive into some examples. But guys, I want to point out now, I could go through so many different examples with you guys, and it would be a waste of time for me to just go through example after example after example. So what I want to focus on today is showing you guys how you can approach the questions or how you can think of them, so that you make it a little bit easier for yourself to understand and therefore solve. All right. So quickly copy down the date and the heading. And we're going to quickly go over the important information that we need to know, right, when it comes to working with surface area and volume. Guys, I would really appreciate it if those of you that have joined could type your first name into the comment box for me. Just your first name is perfect. It just allows me to get familiar with all the students that attend on a more frequent basis. But remember that you're also more than welcome to ask any questions you have in the same comment box. Let's dive into the first of the two measurement values. Surface area, which has a symbol of SA, is equal to the total area of all the faces of a 3D shape. Okay, you need to please remember that surface area is measured in square units or squared units, just like area is. So we're talking about millimeters squared, centimeters squared, meters squared, or kilometers squared. Right. Thanks for all of your names, guys. I really appreciate it. So that's what we need to keep in mind about surface area. Then volume has a symbol of capital V. And if we had to define it, a lot of people confuse capacity with volume. They are not necessarily the same thing. Okay. Volume, guys, is the total amount of space taken up by a 3D object. Please pay close attention to how both surface area and volume relate to only 3D shapes. Okay, surface area we are going to touch on first, but before we do that, there's two more things I want to write down about volume. You need to keep in mind that when we measure volume, it is measured in cubic units. Right? What are cubic units? Millimeters cubed, centimeters cubed, meters cubed, or kilometers or kilometers cubed. Okay, why is there a little 3 that we call a cube symbol? Because we are talking about the length times the width times the height in most cases of certain shapes, right? In other words, we are working with 3 different dimensions. And when you multiply 3 dimensions together, for example, centimeters times centimeters times centimeters, we get cubic centimeters. Okay, so that's just where that comes from. But there's two last things I want to discuss with you guys. When we talk about area, we started off by learning about how to calculate the area of a square and a rectangle. Once we got comfortable with those two shapes, we progressed onto triangles, and eventually we're going to have to pay a lot more attention to circles. But I'm not worried about circles just yet. With that being said, when we want to discuss the concept of volume, volume comes from multiplying 3 dimensions together, right? But we want to know the formula that we can use to find the volume of 3 different kinds of shapes. Now, we can't work with just plain old 2D shapes. We need to be talking about 3D shapes. These are just very rough drawings very quickly, guys. So, first things first, we need to know about the cube. We need to know about rectangular prisms. And finally, we need to know about triangular prisms as well. Okay. So, just as an example, this is what those 3 shapes would look like. Remember, in 3D formats. So, if we want to calculate the volume of these 3 different shapes, remember the first one is called a cube. This is a rectangular prism. And finally, we have a triangular prism. If we want to calculate the volume of these 3 shapes, how are we going to do that? Well, I'm going to quickly show you guys 3 different formulas. Now, keep in mind, these are the 3 basic shapes when it comes to volume. We could still go ahead and talk about cylinders. We could talk about cones, right? Cylinders, cones, and all kinds of other shapes, including pyramids and whatnot. And just like with area, guys, the more complicated shapes sometimes have their own formulae for volume. But on top of that, we can sometimes use what we know from these three basic shapes to help us. Okay, so the last thing we want to write down under the world of volume is going to be formulae. So the volume of a cube. How do we calculate the volume of a cube, of a rectangular prism, and of a triangular prism? I want you guys to please make sure that you write these down because we are going to use them in today's lesson. And while I could spend a solid hour teaching you guys where all of these formulae come from, I find that it's not necessary for right now. And you guys will eventually dive into the depths of understanding where these come from. But for a cube, volume is equal to simply length times width times height. And the same is true of a rectangular prism, right? These are nice and simple. They aren't too complicated because they are basic shapes. Length times width times height for both a cube and a rectangular prism. So for these two shapes over here. A triangular prism obviously has a unique element in the sense that it has triangles as part of the shape. For that reason, when we look at the volume of a triangular prism, we are looking at a half times base times height, right? That's the area of a triangle times the length of the entire prism. Okay, I hope that that makes sense, guys. Okay, this is the volume of a triangular prism. Right, quickly take a second to copy all of that information down, and then we're going to move on to our first example, guys. If you have any questions, please make sure that you ask. I am here to answer it if need be. Okay, so I'm going to write a small subheading over here, examples. And the question is going to be calculate the surface area and volume of the following. Okay. Please make sure that you copy the shape down as well, grade 7s, sorry guys. Okay, otherwise when you need to come back to refer to this, it's going to be a little bit difficult. Okay, so when we start with any surface area or volume calculations, grade excuse me, grade 7s, we need to follow the same sort of structure that we would in a normal area or even perimeter style question. What I mean by that is that we need to start with a symbol, and then we often also start with a formula if there is one. Once we've dealt with that information, we can then go ahead and do all of the substituting and solve for the final answer. So if we look at the following, this is a rectangular prism. Remember, 3D shapes. Let's say we have the following dimensions. 10 centimeters for the width, 25 centimeters for the length, and let's say 6 centimeters for the height. You are often going to be given dimensions in a format like this, guys, where not every single line is going to have a measurement, right? Understanding your properties of triangles, of your basic 2D shapes, you should be able to tell yourself, if this side of my rectangle is 6 centimeters, all of the other individual heights are going to be 6 centimeters, and so on and so forth. Somebody's asked me if I can quickly draw this shape step by step quickly for you guys. So the easiest way to do this, guys, is to use a rectangle. You draw yourself a rectangle, right? That you can do on your own. Then a trick I've just learned for 3D shapes is you make a second triangle and you put it overlapping with your first one, right? So we have two rectangles that are sort of overlapped. Then all I have to do is connect the top left of each triangle. So the top left to the top left, bottom left to bottom left, top right to top right, bottom right to bottom right. Okay, if you do that all with a ruler and your rectangles are the same size, your shape will look very accurate. All right, I hope that answers your question. You can do the same thing with a cube, guys, if you really needed to. Okay, so we now have our shape over here, and we're going to need to calculate the surface area first. How do we do this? We're going to start our calculation by simply saying that surface area is equal to SA. Now, before I go ahead and just start writing a bunch of information, what is surface area, grade 7s? Surface area is the total area of all of the faces of a 3D shape. So if I look at this shape that we've drawn over here, this rectangular prism, we can think of it as pretty similar to a shoebox, right? Think about the different sides of a shoebox, guys. We're going to have the front of my shoebox, which is over here, right? As well as the back of the shoebox, which is going to be this side over here. Right? We've got a front and a back of our shoebox. On top of that, on top of having a front and a back, we have to have a left-hand side and a right-hand side. Yeah? So here would be our left-hand side, and here would be the right-hand side of our shape. So we've got the front, the back, the left, the right, and that only leaves us with two more sides. We need to also have the top and the bottom of our shape, right? Right over here on the top and over here for the bottom. So we know that this shape of ours, this rectangular prism, has a total of 6 sides, 6 faces. So keeping this in mind, when we calculate the surface area, we need to have 6 different calculations. So when we write out our working out, We can even include this if we wanted to and say we want the the top rectangle plus the bottom rectangle. We want the left rectangle and the right rectangle. We also want the front rectangle and the back rectangle. This is not an official step that many teachers will show you guys, and I think that it's an important one for me to just point out because you've got to keep track of where on the shape you are. So I need the area of all 6 of these sides. That's what surface area means. So let's begin with the top of my shoebox shape, right? This over here would be the top of my shape. Now, how would I find the area of a rectangle, right? Remember, for surface area, even though we're looking for the surface area of a 3D shape, we are focused on all of the 2D pieces. So the rectangle on the top, we can see, is the same as the rectangle on the bottom, right? And if you guys want, you can go ahead and add in all of the missing measurements if you feel a need to do so. If it helps you, you're more than welcome to do it, right? I know that all the tall sides are going to be 6 and all of the longer sides are 25. So it becomes a little bit tricky only because there's only so much space on these shapes, especially when they're printed out in an exam setting. But looking at this rectangle that I have on the top of my shape, I can see that it needs to be 10 centimeters long and 25 centimeters wide, right? So we're going to start with the top rectangle, which is going to be 10 times 25. This is the top of our box, but I have the same exact measurement at the bottom, so I'm going to repeat it. Plus 10 times 25. All right? These 2 brackets are for the top and bottom of my shape. Next, we can move on to the left and right-hand sides. Okay, just a second, please, guys. Okay. Very quickly. Looking at my shape once again, I want to now take a look at the left and right-hand side. Here is the left-hand rectangle on my box, and over here we have the right-hand side of my box. Right? These rectangles are also going to be identical in size. So how do I find the area of this green rectangle now? Well, I can see it's 10 centimeters long and 6 centimeters wide. So I will have 10 centimeters long times 6 centimeters wide, but the left and the right-hand side of my rectangular prism are identical, right? These 2 rectangles for the left and the right-hand side are equal in size, so you can add those 2 together. And if you want to continue this color coding, you're more than welcome to do so. Finally, that leaves us with the rectangle at the front and at the back of our shape. So, looking at our rectangular prism, I now need this rectangle over here in the front, as well as this rectangle over here at the back. Right? I need both of these rectangles. How do I find the area of this rectangle? Well, I can see already that it's 25 centimeters long, but I can also tell that it needs to be 6 centimeters tall. Right, so these rectangles are 25 centimeters by 6 centimeters. So we can add this onto our calculation, 25 times 6, but that gives me one of the rectangles. So because the front and the back are identical in size, we can add on a copy of that calculation. When we look at our work at this point, grade 7s, you should be able to tell that we have 6 calculations, or the other way to see it is 3 sets of 2. Okay. If we go ahead and do all of this work in our calculator, 10 times 25 is 250 plus 250. In the orange brackets, 10 times 6 is 60, and we have that twice. Plus in the green brackets, 25 times 6 is 150, which also occurs twice. When we add all of this together, we're going to have a total of 920 grade 7s. But because we are working with surface area, we need to pay attention to what our final answer is going to be. Remember, there are centimeters in the diagram, but because we are working with area, we must use the squared version of this unit. So 920 centimeters squared is the final surface area of the shape that we've just drawn. If you guys want to quickly go ahead and double check all of those calculations, you are more than welcome to. Okay, so surface area isn't exactly very difficult. It's got to do with the normal area that we practice with. It's just that we add a few of them together, right? So surface area is not tricky, but there are so many different opportunities for you to make silly mistakes, grade 7s. So you've really got to be paying close attention to what you're doing. And it's just a piece of advice. I would recommend that you guys use some kind of labeling system, numbering system, or color system to help you keep track of which sides of a shape you have already dealt with versus which you still have to work with. Okay, so you can see here that we've got different colors for different but equal parts of a shape. The front and back are equal, so they are both green. The left and right are equal in size, so they are both orange. And the top and bottom are equal, so they are both yellow. You don't have to do it the same way as me, but find a way that works for you to keep track of the sides of a shape that you have worked on, and be very careful of scribbling on your only copy of a shape in your test. Rather, if you do want to do some scribbling on the diagram, redraw the picture on the back of your page or in a spare space on your test paper, and then you can go ahead and scribble as much as you like. All right, so that's actually the harder part of this calculation, grade 7s. We now just want to quickly touch on calculating volume, and I have already told you guys that we have a specific formula for the volume of a rectangular prism. So I'm going to quickly copy our shape over here, and we are going to move down, and then I'll come back up so that you guys can finish copying. Looking at my shape over here, I was already told that the volume of a rectangular prism specifically is the length times the width times the height of my prism. The length comes first. That would be this 25 centimeter length over here. So we can fill that into L's place. Then W is next. The width of my shape is 10 centimeters. please make sure that you don't confuse your dimensions. Okay, finally, we have a height, which is over here, and that is 6 centimeters. So you can add that on too. And when you go and find the answer to this, guys, I would recommend you deal with the values first. 250, or sorry, 25 times 10 is 250, times 6 is 1,500. And we have multiplied 3 centimeter symbols together. And this makes sense because in our notes, we pointed out that volume must always be measured in cubic units. So there we go. You can see how surface area seems like it's simpler, but we actually do a lot more work when it comes to surface area. Volume is slightly easier. Now, looking at this shape over here, in case some of you were a little confused as to how I got the numbers for these rectangles above over here in the first example, please keep in mind that all of these rectangles combined tell us that the 4 pillars on the corner are all going to be 6 centimeters. The 4 longest edges are all going to measure 25, and the 4 shorter edges of our shape are all going to be 10 centimeters. So make sure that you are comfortable with identifying the width, the height, and the length of a specific 3D shape using any of the lines, not just the values that you were given. Okay, now I'm sure you guys want an opportunity to copy, so there we go. Copy down whatever it is you would like to. And if you have any questions, now would be a good time to ask. Is there anything you would like me to repeat or quickly brush over once more from this example, grade 7s, or are we all happy? Okay, I'm not seeing any specific questions, guys, so I'm going to assume that everyone's relatively okay for now. Remember, guys, there are a lot of marks to be earned in a question like this. In a volume question, you would likely get 3 marks if it's something simple like this. Okay, so you already get 3 marks for your volume. Surface area, however, you will get 1 for each different calculation and 1 more mark for recognizing that there's a duplicate of each, and 2 marks for your answer. So in this sort of situation, you'd be looking at 6 marks for your surface area calculation. Please remember, I cannot speak for all of your teachers. Everyone sets tests differently. But what I'm trying to point out to you is that this is already 9 marks, which is pretty close to 10. And if you think about the fact that most tests are out of about 60 marks for 60 minutes, that one question is already more than 10% of your test. Okay, so it's worth taking the time to work your way through these questions slowly, making sure that you are working accurately so that you don't make silly mistakes. All right. It is possible that you could get more marks than this or even less marks, but this is a guideline to give you guys an understanding of what this kind of work is worth. Okay. I'm going to let you guys finish copying volume very quickly while I move on to example number 2. Guys, because these are very long questions and there's a lot to sort of consider in each one, I'm only going to do one last example. I'm going to go through it in detail. And so if you guys have questions about why I am doing something or how I'm getting to a specific answer, that is what I'm interested in helping you guys with. Okay. If you want to draw this shape, we are going to use 2 triangles. We are now working on a triangular prism. When drawing a triangular prism, you can set up 2 triangles with one higher than the other triangle, right? You can see how everything is aligned over here. And again, in a very similar fashion, we're going to go ahead and connect the top of the triangles together, the bottom left of the triangles together, and the bottom right of the triangles together. Okay. There is our first line. Here is our second line. Some people prefer to make this a dotted line because you can't actually see it. That's completely fine. If you want to do that, you're more than welcome to. And then do your last line in the front. This is an example of a triangular prism, grade 7s. I'm going to add some measurements onto it, and we're going to calculate both its surface area and its volume, and then we will be done for today. Okay. All right, guys, quickly go ahead and copy down this shape and the information that you see I've drawn onto it. And then we're going to go ahead and calculate both the volume and the surface area of the shape. If you have any questions, you're more than welcome to ask. I haven't seen anything just yet. Right, keep in mind this is a triangular prism. So we want to start with understanding how we are going to approach the surface area calculation. That is our main concern for as of right now. Whenever we start a surface area calculation, please remember to state that surface area has the symbol of SA. Okay, how are we going to find the surface area of this shape, grade 7s? Well, let's take a second. I'm going to quickly draw a very rough second example over here. Okay, if we think about a triangular prism, we need to consider all of the different faces that it has. So, first things first, we have a triangle, okay, a triangle at the front and at the back. So we have 2 triangles to worry about, but then we also have a total of 3 rectangles. Where do I get 3 from? We have one on the right, one on the left, okay? And we also have one at the bottom. There are three different rectangles that are actually all going to be the same size. Okay, now this is where you really have to practice trying to almost take a screenshot of the shape that we are working with and rotating it in your head. So let's think about this carefully. If we had to write a little list down for ourselves so that we can keep track of what we're calculating, we can use a little bit of symbols and codes if we want, but make sure that your teacher can understand it. We have the front triangle plus we have the back triangle, right? Those are going to be the same size. Then we're also going to have three rectangles, okay? You can say that we're going to have the left rectangle plus the right rectangle plus the bottom rectangle if you want. You can write codes however you like. It really depends on what you guys want to do. But let's say we'll do this for now, right? We have the right-hand rectangle, which is the symbol R, the left-hand rectangle, which is left, and the bottom rectangle, which is B. Okay? We want to calculate the surface area. So how are we going to do it? You need to make sure you state the formulas that you are using when calculating the area of each of these shapes. So we know that the area of a triangle is going to be half times base times perpendicular height. Okay, that is our first triangle. Plus, again, we have half times base times perpendicular height for our second triangle. For the rectangles, we simply have length times width, and this is repeated 3 times over because they are, rectangles, guys. I don't know if I said triangles there by mistake. We have 3 rectangles, one on the left, one on the right, and one at the bottom. The way we calculate the area of a rectangle remains the same. So this is how we're going to go about calculating our surface area. And I think it's really important that you guys have your own sort of game plan to use when calculating the surface area of complicated shapes. You do not have to do it the same way as me, but I'm showing you guys that it's helpful to have a step that you include that helps you to keep track of what you need to calculate in your question. Okay. So let's think about our triangles first. If we look at our triangles, they have a base of 30 millimeters, right? 30 millimeters is the base. And in this case, we were lucky to have been given the height. The height for both of these triangles would be the same. So they are 25 millimeters. So in my calculation for my triangles, I'm going to say the following. A half times. The base is 30 millimeters, while the height is 25 millimeters. Remember, we are looking for the perpendicular height, not the slanted height. Both triangles are the same, so again, we can repeat this and say a half times 30 times 25. Then we have 3 rectangles to consider. The one on the left, the one on the right, and the one at the bottom. Now, if I had to color in the front, let me quickly do this. If I color in the left-hand rectangle, right? We're talking about this rectangle over here. It covers most of the shape, but that's okay. This is the left-hand rectangle. We can see that it is quite clearly 80 millimeters long, and it needs to be 30 millimeters wide, right? If I just have to erase this here, there was a measurement of 30. So our rectangle needs to be 80 millimeters by 30 millimeters, right? I hope that that makes sense to you, all of you guys. Now, if I take a second and color in the right-hand rectangle, that would be this rectangle over here, right? The rectangle on this side, weirdly enough, is also going to be 30 millimeters wide. But how long is it? It also has to be 80 millimeters long. So that is the second rectangle that is now 80 by 30, right? 80 millimeters by 30 millimeters. And again, if I had to quickly remove all of this coloring in, and we now think about the base rectangle, this one over here at the bottom of our shape, right? What size is this rectangle going to be? Well, surprise, surprise, it's 80 millimeters wide or long by 30 millimeters wide. So all three of my rectangles here have the same dimensions. So what's going to happen is when I complete this calculation, I'm going to have 80 times 30 repeated 3 times over, because there are 3 rectangles that are all equal in size. Okay. Now, when we simplify and start getting our numbers, a half times 30 times 25 for our triangles comes out to 375 each. Then 80 times 30 for our rectangles is 2,400 each. So we're going to have 3 copies of 2,400 for the 3 rectangles that we were working on. This leaves us in a position to add everything together, grade 7s. This is why you need your calculator. And when we add it all up, we get quite a large number of 7,950. Remember, this is a form of area and we are working in millimeters. So our final unit needs to be millimeters squared. Okay. Seven 7,950 millimeters squared. All right. So again, guys, this is another way that we go about calculating the surface area of a shape. And again, this would give you a lot of marks. If I were the one marking this, you would get 1 mark for each of the formulas that you used. You would get a mark for your triangle and 2 marks for your rectangles and 2 marks for your final answer. So 1, 2, 3, 4, 5, 6, 7 marks, okay, roughly, for your surface area calculation. It's a lot of marks, guys. And your teacher will usually only give you one example of a question like this in a test or an exam. So don't think that you're going to have an entire test of 6 of these questions. They likely only get tested once. And finally, guys, we need to talk about the volume. Okay. We always start by stating that volume has a symbol V, and we are talking about the volume of a triangular prism. Okay, now at the beginning of the lesson, I gave you guys a formula that you need to slowly practice using. The volume of a triangular prism is a half times base times height, with everything being multiplied by the length of the prism. So what I'm going to quickly do is make a copy of the prism that we were working on, and then I'll give you guys a chance to copy in a moment. But how would we calculate the volume of this prism? Remember, volume is about the amount of space that the entire 3D shape is taking up. You can imagine it as though you were being asked, how much water or fluid can I fit inside a shape? So let's go ahead and substitute. I want the volume of this triangular prism. So the half stays as is. What is the base of my triangle, guys? We know that the base is 30 millimeters. And finally, what is the height? Remember, we are talking about the perpendicular height. Excuse me, not the slanted height of a triangle. So we are paying attention to this vertical height over here, not the slanted line on the side, knowing that the height is 25 millimeters. But we're not done just yet. We would still need to multiply this by the length of the shape. Right here is the length. This is 80 millimeters. So we add that onto our calculation. And now we must first solve what we see inside of the brackets before we may move on to working with the 80 millimeters on the outside. A half times 30 times 25 is going to give me 375. Right? Millimeters times millimeters gives me millimeters squared. But we won't worry about that for now. Everything inside of the brackets is equal to 375, and we can multiply this by 80. And when we do that in our calculators, guys, we get quite a perfect answer of 30,000. But remember, what is our unit? We are working in millimeters, but because this is volume, it needs to be cubic millimeters. So the volume of our triangular prism with these dimensions has a volume of 30,000 cubic millimeters, guys. And so there you have it. Again, when it comes to marks, you would get a mark for your formula and a mark for using the correct numbers, maybe even 2, and then 2 marks for your final answer. And so again, just this volume calculation is probably worth somewhere around 5 marks in its own right. All right. So there we have it, grade 7s. This is how we go about calculating surface area and volume for 3D shapes. There are other complicated shapes that you will eventually get to practice with, but guys, these are the hardest shapes you are going to have to worry about for now, and I really do hope that you will practice finding surface area and volume. While it might be pretty easy for you to watch me find these answers, you've got to keep in mind that maths is not a spectator sport. You have to try this on your own. Otherwise, you'll never really know if you are able to remember all of the steps, identify the correct dimensions, remember the correct units, and so on and so forth. Okay. Now, guys, today's lesson was jam-packed at the very least with information. And I haven't seen any questions yet, which is odd because I'm not sure if it's a good thing or a bad thing. But like I said to you at the beginning of today's lesson, I wanted to spend a lot of time on sharing how we want to approach these questions as opposed to just going through 5 different examples with you. So I hope that from today's lesson, you can take away an approach that you can use, right? Sort of a mental framework that you can use to help you view these questions in. Um, when it comes to working with measurement like this, guys, there are lots of examples we could go through, but I hope that you guys have learned how we break these more complicated questions down into smaller pieces so that we can find the answer. Okay. Remember, you do not have to lay out everything in exactly the same fashion as me. You don't have to use exactly the same steps or order as me, but you do want to make sure that whatever you do write down is in a very logical order, and that anybody that looks at your test or answer book can tell exactly what's going on. All right, they must be able to follow. So guys, there we have it. That is our lesson for today on surface area and volume. Um, oh, sorry. I don't know what's going to happen there now. There we go. So, um, guys, just very quickly, I would like to know if you have any questions for me. If there's something you would like to know, now would be a good time to ask. Otherwise, you guys already know that we want to use iRainbow to go and practice this kind of work. Okay. I'm going to very quickly show you guys. Let me just quickly check. Sorry, just a second, grade 7s. Now, you might realize that you don't even have to work on such complex shapes, but I would really recommend that you guys practice working on um, identifying the more complicated shapes, because the easier it is for you to break them down into simpler pieces, the better you are going to be at this topic. Okay. Very quickly, guys, I haven't seen any questions, so I'm going to change screens and quickly show you iRainbow. Obviously, knowing how long it takes to solve these questions, I cannot go through examples with you now because we are already out of time, but I'm going to stop sharing my screen very quickly and show you a different screen, grade 7s. If you need me to go back to that screen so that you can finish copying, please let me know. All right. But you guys should be able to see iRainbow now. And on your screens, we are on the home page for iRainbow, right? When you open up iRainbow, guys, to find the quiz for this section of work, we're going to need to click on measurement at the bottom right over here, the island of measurement. We then want to click on measure geometric shapes, right? The third topic. And under this section, guys, you can see quizzes on everything that we've been chatting about for quite some time now. For example, today we chatted a lot about surface area and volume. So let's say, for example, I clicked on the volume quiz and we can try level 1. Over here, you need to find the volume of a cube, right? I've given you guys the formula that we use to calculate the area of volume, of a cube. 3 times 3 times 3. The length times the width times the height, and that's going to give me 27. right? Just as an example. As you progress through this quiz, you'll see that we start looking at slightly different shapes. These are also rectangular prisms, right? So you're going to want to use what you know about prisms already and the formulas that I've discussed with you to try and complete these questions. The most difficult one or most difficult examples in this quiz are going to be these grade sevens, the volume of triangular prisms, which we've discussed in depth. Remember, I have given you the volume formula for this kind of prism, and you're going to have to use it to find the correct answer. You must make sure that you write things down on a piece of paper in front of you, like we have over here, because there's a lot to remember for a test or an exam setting. Okay. Please do not just go ahead and throw everything into a calculator and type the answer in. All right. So grade sevens, I really hope that you guys will go ahead and practice the quizzes on surface area and volume. There's a lot of questions you can use to test yourself, and you've now also had your lesson on this topic. So you can even go ahead and mix it all together if you're feeling comfortable with all of the work that we've completed. If there are some of you that are new attending today, grade sevens, please keep in mind that we have recordings of all of our lessons. So if you want to go and watch last week's lesson, you can do so by going back to the 16th of April on our YouTube channel, and you can find the recording there, or you can also find it on the Facebook page for iRainbow. All right, you can access the recordings of these lessons for free on either platform, and it's completely up to you. All right. So, guys, you now know where to find the quiz. I hope that you will practice it. You will see that it becomes a common theme that during our lessons, I point out to you guys that I cannot go through an endless number of examples, but instead it's better for me to try and teach you guys how we want to view things, right? What kind of steps we can take to approach questions of a certain style, as opposed to just getting you to memorize every single kind of question on its own. All right. Guys, I haven't seen any questions, so I'm going to assume that you guys are done for today. I do appreciate you guys attending, and I hope that there was something valuable that you learned. Please remember that our next lesson is going to be next week, Wednesday, again, from 5 o'clock in the afternoon to 6 o'clock. I hope that I'll see you guys there. I really, really hope that today was a valuable hour spent. But guys, thank you so much for attending. I'll speak to you all again next week. If you have any questions, I'll stick around for one more minute. But beyond that, guys, if you have any other questions that you think of during the week, just bring them during our next lesson. Okay. Thank you so much, grade sevens. Have a fantastic week ahead, guys. I'll chat to you all again next week. All right, guys. There haven't been any more questions, so I wish you all the best. Have a fantastic week ahead, and we'll chat again next week, Wednesday at 5 o'clock in the evening. All right. Thank you so much, guys. Enjoy.